Hi there! If you saw my latest repair video on the Vane Cap B642, you'll understand that I'm on the lookout for some accurate capacitors for calibration reasons. Accurate capacitors are hard to come by and very expensive. When I saw this decade on eBay for very little money, I could not resist. It's marked CD3 and offers 3 decades, 1 microfarad, 0.1 microfarad and 0.01 microfarad. Rated for up to 350 volts DC and made by Lionmount, and it even has a discharge button, which is very nice. The sticker on the side states that the 0.01 microfarad decade has an accuracy of 1%, while the 2 higher decades have 2%. For affordable capacitor references, that's quite good. For a first test, I connected my BM869S. I did not bother to null it first because all I really wanted to know at this stage if there are any problems, as frequently are the case with eBay stuff. So going over each decade and just checking to see if I get about the right value. No issues for the first decade of 10 nanofarad steps, moving on to the second decade in 100 nanofarad steps. That seems to work just fine as well. Moving on to the highest decade of 1 microfarad steps, and there's a problem. After 3 microfarads I'm getting wrong values. Something is definitely broken here, or maybe it's just bad switch contacts. The front plate is fixed to the box using normal wood screws. In all, a total of 6 screws have to be removed. I am as curious as you are what's inside. Let's find out. Oh dear, what a mess. Lots of degraded foam crumbling to bits. The 2 higher decades were for some reason wrapped in foam. The one on the middle decade seems still intact, but the one for the 1 microfarad decade has aged badly. I can also see at least 3 broken wires on the 1 microfarad decade, which would explain the problem. They are hard to see on camera, especially the ones wedged between the foam mess and the switch. Before any attempt at fixing, that foam mess has to go. It is difficult to see where the wires are broken off from the switch. I marked them with red circles. Luckily, the positions and lengths of the wires leave no doubt where they should go. Besides, all 3 decades are wired exactly the same way, so I could simply compare with one that's still working. As to why those wires snapped, there's little doubt. There are no less than 4 big and heavy caps clamped together with some metal bracket that is fixed on the front plate and also holds 2 more caps on the other side. Once the foam between the caps and the front plate disintegrated, there was nothing to stop the left bracket from bouncing up and down at every opportunity until the wire snapped. This did not happen on the other side, even though that bracket has also lost its foam support, but this bracket carries only 2 smaller caps. Hence less mass over a much shorter lever arm. For reattaching the wires, I first had to remove a bit of the wire isolation and tin the end. Next, I bent the wire so its end pressed against the place where it was supposed to go. And finally soldered it back in place. I did the same with the other 2 wires, but they are in a position that makes it impossible for videoing the process. I made a rather makeshift support from stacked bits of wooden coffee stirrers glued together and include that in between the left bracket and the front plate. That stopped the bouncing. And with that, the last decade is now working just fine. I speed that test up a little because it's really rather boring. Last thing to check is the discharge button. Setting the meter to ohms, and indeed pressing the button shortens the connection through a 10K resistor. Maybe it's interesting how these decade capacitance boxes work, because it's quite different from decade resistor boxes. This box, as well as some others I've seen, use just 4 capacitors. I show them here as 1, 2, 2 and 5. For the 100 microfarad decade, these would be 1, 2, 2 and 5 microfarad. For the 100 nanofarad decade, these would be 100, 200, 200 and 500 nanofarad, and so on. By clever and rather complex wiring and switching using multi-level rotary switches, these 4 capacitors are used by themselves or in parallel to form the 10 capacitance values of a decade. The plus sign in my table here obviously means connected in parallel. So for example, you get 3 by putting the capacitor with a value of 1 and one with a value of 2 in parallel. If a capacitor with a value of 5 is not available, it might be by itself approximated through the use of permanently wiring a couple of available capacitors in parallel. For example, in this decade, the 5 microfarad cap is actually itself made of 3 parallel capacitors with the values of 2, 2 and 1. Here's how that looks with the capacitor values superimposed. The two 2 microfarad caps on the most left plus the smaller 1 microfarad cap are permanently in parallel and act as one 5 microfarad capacitor. The other 3 caps act on their own as the 2 times 2 microfarad caps and the 1 microfarad cap that are needed for a total of 4 caps making the decade. Obviously, a simple rotary switch is not going to be able to do the complex combinations of adding capacitance values. In this decade, they use rotary switches with 2 levels and a lot of wire links between them. Interestingly, they were able to find 50 nanofarad and 500 nanofarad capacitors, which is why the other decades do not need a messy substitution for the 5 value. Unfortunately, only the 10 nanofarad capacitor allows me to read the full marking. For all others, the marking is obscured by the way they are mounted, and I did not want to disturb them too much. Last not least, I tested the accuracy of my repaired decade box against the value indicated by the switch position. The problem is that my LCR meter itself has a limited accuracy, which is indicated by the red lines. If you remember, the first decade up to position 10 or 0.1 microfarad is supposed to have an accuracy of 1%. Well, the graph shows that it's within 0.5%, but then the LCR meter itself has only 0.5% accuracy, so the deviation of the decade against the switch position may be closer to the 1% border or much closer to 0. It's impossible to tell. It certainly seems that the second decade is less accurate than the first one, but still in the 2% spec. The last one is again much closer. All in all, the Lionmount CD3 Decade does seem to meet its specs and is certainly a welcome addition to my references, as limited as they are. If you like my videos, don't forget to subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided becoming a Patreon. That would really help this channel. Thanks for watching.